Okay, Rajesh, I think you can start.
Okay,
I'll just
thank
give
you.
a brief introduction about Rajesh. So Rajesh actually is um, has taken the black belt training during the month of August from us, and then he completed the exam, and then after passing the exam, he was certified as a black belt from Iceqbs. And then for the last 1 month, for the entire month of September, then he was getting the project guidance from us, and he has completed his one project on his own. He has taken actually a problem for his company, and he has followed the DMAIC methodology for solving the particular problem. So I'm really happy to say that you actually was very interested in he was very attentive in the class, and then he took the certification exam just within a week, just only a week after completing the session. That is a 4 week session, and then he has also completed the project within 1 month. So I really appreciate his interest for following the Six Sigma methodology, and I hope that he will be doing more projects so that he is getting more acquainted with the DMAIC methodology, and then he'll be able to solve more and more complex problems. So with this introduction, I'll just hand over to Rajesh. So Rajesh can start explaining about the project what he has done.
Thank you so much, sir. Thanks for the brief intro. And good afternoon, everybody who in the call. Before going into the presentation, let me introduce myself. Myself, Rajesh Balan. I'm heading the electrical, electronics, and embedded team of Hubble India. I'm working as a senior manager engineering in Hubble. Hubble is a US-based company. Probably you can check my LinkedIn profile to have more details on that part. And also, I need to thank annamalai sir for his excellent guidance on the throughout this project and the training. So that has made me to come to this level. Thanks a lot for the support, sir. Okay, so moving on to the project point of, and probably I had taken a project from part of my organization, and more or less this is not an exact project. We are trying to simulate the project in some data actually, and the project what we have taken as the medium voltage product lines, and the aim of the project is to reduce the NPD timeline of the project, the overall NPD timeline of the products.
NPD is new product development, right?
Yes,
New product
exactly.
development, yeah. New product development timeline.
So this is the agenda what we'll be seeing in the coming slides. So as Sarah told, this is, as I told you in the intro itself, this is the quick overview of the project. Our aim is to reduce the medium voltage timeline products timeline, and current the product timeline is taking an average of 40.7, approximately 41 weeks for a product launch. And then now we are trying to bring in that product timeline from 15 to 30. That's the goal what we are trying to achieve here. Probably where I'm taking it as the sponsor and the coach for this project. And team members are the black belt participants who are participating part with me in the training point of view. The method what we approach is the DMAC methodology, and this is the thing what we are implementing in this project. The scope of the project is more into, we are concentrating more into the NPD timeline, reduction of the ME products. And the problem is actually whenever you have a project or a requirement, you have plenty of change requests coming from your customers. So that is not part of this project where we can consider the change requests in the scope of this project. And also we do have some dependencies from the external vendors like test labs or some vendors which cannot be considered part of this project scope. Is there anything else you want to add in this slide, sir?
Oh, this okay. Yeah. Okay.
Okay. Coming to the define phase, actually, this is a critical requirement of the customer. The customer, everybody wants the things to be prioritized, right? That's the aim of the customer as well as the company also. So what happened is actually we had a feedback that the customer had a comments that you are doing a good product, fine, but at the end of the day, your product timeline is a little bit slow, where it takes more time to when you come to the market point of view. That was the one feedback what we got from the customer, where we have, and where the critical thing is the number of iterations. For example, if a project, if you do I explain the slide that very clear for you, where the key drivers were the iterations and the number of weeks of the taken to deliver the projects. Okay, so taking the number of weeks as a key measurable. So what we thought is considering the Y key contribution to be measured as a weeks. So we had analysis what are the things we need to consider here. For example, how we calculate the overall timeline. For example, when we have the start timeline, and that is simply whenever we get the request for the new design, that is the start. The clock starts there, and then when we give the product to the market, then we have ending to the product comes to the end, project comes to the end. Overall, it's a weekly roundup from the start date to the end date. And then again, how we are calculating this again, when you get the request from the US design team, and that is a clock starts there. And then when we deliver the output, the design and testing documents, then that's the area where we stop our activities. Overall, we have been tracking in the Excel. We have some tools for that to track the project. And overall we have the project management team who monitors this overall. We are taking the data from the last 2 years from the company point of view, and this is the overall timeline of this project. And then what are things we try to consider the in the time parameters. This is task parameters what we consider. Okay, moving to the process flow. This is the process flow, how it happens in the new product development point of view. Whenever we have a design requirement, and then we have, for example, we have a product. I'll tell you in a very simple example. If you have a fuse in your home, then what happens? In your fuse, what happens? You have 10 amps the requirement. So what is the requirement of the fuse? The fuse need to withstand for 10 amps. And then whenever the current flows beyond some limit, the fuse need to operate. That's a very basic requirement. So if you're going to have a requirement like that, when you have a requirement, we do a calculation of that requirement, a design calculation of the requirement. And then what happens again depends upon what is the material. I'm telling a fuse as a very simple example, but we have switches, arresters, insulator, like that. We have many electrical products which goes into very high voltages, 36 kVA, 28 kVA. That's the voltage level what we're handling. So what happened? We do the modeling of that. Modeling of that of the based on the electrical parameters. We do the calculation. We model them. Where they're going to be mounted, where they're going to be, what is the end customer's requirement. We do a modeling based on that with a material selection. Once this is completed, what happened actually is we try to get a quotation for the proto samples, and that what happens once you get the quotation, that goes to the vendor for the component manufacturing. And then when we get the components from the vendor, we do the assembly of the components in the shop floor. After that assembly of the new product what we design, that assembly is done in the shop floor. Then we ship that to the lab where we need test. Most of the labs, as I told you, as more of a high voltage, we need to ship them to the labs with high voltage capacity for testing them. So we ship them to the lab, that we do a testing in the lab. If the testing passes successfully, then we go for a certification approval of that product from the lab. Then we hand over that to the production. If the testing fails, then we need to again go to the design requirement. We need to analyze that again. Then cycle again continues in this area.
Okay, fine.
Okay, so what we saw was here one example. For example, what happened actually, so something like that, when this will happen for multi times. For example, we have a requirement, and then it may be iteration 1 or 2 or 3, and then we can go for the final iteration. This is a problem what we face here actually is, it's going to be one iteration that's really good, we are happy with that, but normally don't happen like that actually. What happens, it will happen iteration 1 or 2 will go when where we need to achieve the required results in the labs, so that the product performs as per our requirement or the standard requirements. So this is the key bottleneck or the key area what we are going to address in this project. Okay, as I told you, this is a cycle where we the engineering team, and then we get the design requirements, and then we follow the design process from our end. When the design process completed, we give the product, get the product approval, and then we launch the product to the market. This is the overall cycle. Okay. The timeline of the project is approximate data taken for the last few years, 2 years, where you can see that there is a big variation in the number of weeks, where this orange indicates you the number of weeks of the each project, and then in the right side you will have the number of iterations. I mean that also will be varying depends for the each project. So our goal is to reduce the weeks as well as the reduce the number of iterations. Okay. Moving to the project charter, as I communicated already, we are our aim is to reduce the medium voltage product timelines. Rather, I'm taking the lead of the project, and these are my team members, and SAR is responsible for this. And then the key stakeholders are whenever do you have a product line, new product development, then the key stakeholders will be the manufacturing team because they are the end user. They are going to manufacture product. Quality team need to be aligned with your new product development, and then production team again they need to be aligned with your manufacturing the new product, and then marketing team they are the person going to sell the product with the customers. So these people are key stakeholders who they'll be giving the key inputs for you during the project driving time. And you see the problem, current problem what we are facing, the NP time is almost 41 weeks approximately, which is higher than the company standard. The company wants more, we will need to be reduced in that angle. And our aim is to reduce the timeline from 15 to 30 weeks from the average of current timeline of 41 weeks approximately. Okay, and then what happens actually here is, okay, again as I told you, the customer is a little bit not happy. The NPA timeline is taking more time. But what assumption we can make is actually we will have we need to take assumption here. There, there will be a delay only in the project point of view, not on the resources point of view. In this case, I take assumption my resources will be stable in the organization. They are not going to switch the company during this project scenario. And then the second part of the charter, again, the cost workout, we have a 13 slide 13, which it has a detail of all the things. And what benefit you are getting is we are entering early to the market. And then probably what happens is we are trying to reduce the timeline. Reduce the timeline is we are trying to fast track. Then that means we are putting the pressure on the resources, labs, everywhere, and the vendors, everywhere we are putting the pressure. That means obviously there is a area where you will not meet the standard requirements, or your product may fail in the lab. That's one critical thing what you may face in the end of the lab results. That's one area what you need to consider as a risk in this timeline reduction. And our scope is to only concentrate on the NPT timeline reduction of medium voltage product lines. And as I told you, we are not considering the lab delays or the proto sample delays will be out of scope of this project. And again, this are the team who need to approve the final end of the project, and this is the timeline of the project. Any questions or any from your end? No?
Yeah. Carry on.
Thanks. Okay. And coming to the cost analysis point of view, as I told you, for example, if you take one iteration, here there's a split up of the cost which is used for a project. For example, resource point of view, we are taking for a 16 weeks, calculating a 40 hours of weeks per 1 week, and then we are going to approximately charge a $25 per hour. Approximately, what happens? We are trying to have a 16K for the resource point of view. And the lab testing is a very key contribution factor because we are going to be blocking the testing labs in Kima, Netherlands, or Canada PowerTech lab, a very high-tech labs in the world, and their cost is almost 80 to 90K per week. That is the cost what they charge us actually. And again, transport of the materials from the US to Canada or Netherlands or India to Canada. That's the way the cost 3K. Proto sample again depends upon when you have a new design, you will be making a new proto sample, a new product. And that varies depends on the project. I've taken approximately 10K here. A total for a single iteration, we are going to take a cost of 109K or 110K approximately. So if we convert this into an annual cost, so we are considering the 40 weeks for a project, and then it's approximately 2.4 iterations as average. So considering things, we are having a total of approximately 2,757K that is spent done by the company for approximate of 10 projects. This is the current expense for the company is taking off. So as we told, we are going to reduce the project timeline from 30 weeks, or if we 30 weeks, if we take reduce this iteration from 2.4, it comes approximately a 1.8 iterations for you. In that angle, when you're trying to convert that calculations in the projected savings, we are trying to get the annual value saving of say value of 1975 case. Probably it's not a saving. I'm wrong here. So this is a saving what we are going to be getting. So the actual plus the projected values, we may get approximately 1800K saving per annum in the organization point of. That's the thing what you're trying to do. If we achieve 30 weeks of product launch with 1.8 iterations.
Okay.
Okay. So moving to this high level risk assessment. Okay. So what are the current risks what we are having seeing? What are the areas we feel is the risky area here actually? Within the project driving areas. So the key factors are the communication gap between the India and the US team. This happens all over the world, not only in our projects. So what happens when there is a gap, then what happens? Obviously, there is a lag in the update of the project. There is a lag in the project drive also. So that is one area what we need to address. Like that, we have the technical skill required for the project, drive the project. That is something a resource is not capable enough to handle that, or the resources having a technical skill but doesn't have a exact modeling skill, so he can bring in his knowledge into the modeling. So he can design but he can't model that. That's another problem. After modeling only we can communicate that to a drawing to the vendors for making the samples. So this is another skill which is required the resource point of view. And again there is a delay in the vendor from the quotations. The vendor is not having a bandwidth to make the required components for us, or the components once you get from the vendors are not matching as per our dimensions or requirement, or there is a shipment in the delay. Once you complete everything you are fine, but you want to ship to the lab and then there is a shipment in the delay there, then you are totally lost in the testing point of view. And finally you do everything and you are not meeting the standard requirement, then another critical area where you need to address. So this is the high risk areas where we do some analysis and we try to have the rating for them. Okay, moving on to the measure phase, and this data is not too clear for you, but this is the overall the different projects what we have taken, and then some projects will have one iterations and some will have two iterations. Again, depends upon the overall timeline has been calculated for the 10 projects here actually. So if you have the highest, we will be having a 4 iterations, and then the lowest we may have one iteration in this figures. So this project has only one iteration. By this, we calculated the average week and the project iteration based on the past data. Okay. After having this data, we try to do some kind of analysis in the Minitab with the charts what we have. If we first we had a run chart, and then if you see the run chart here, the run chart is we have variations there, but there is no special cost variations in this run chart. So that's one thing what we observed from the run chart. Sorry, you want to add anything here?
That's okay. Yeah, normally when we collect the data, we have to ensure that that is coming from a stable process. So before even starting the collecting the data, we have to check whether the process is running under the influence of the common cause variation. So that is why you do the run chart. So in the run chart, what is expected is the individual points has to be above and below the middle line, randomly distributed. So here for the past data also, we are seeing that it was more or less stable. So whatever the variations were there, it was coming only from the common causes. So that way, the Six Sigma project will be really helpful for solving the problem.
Sir, one question, sir. Can I ask?
Yeah.
So this run chart is basically the number of weeks is in the y-axis, and x-axis is the number of projects or number of iterations actually. How you are taking? Suppose one project you have 2-3 iterations.
No, this is the total weeks taken for a project, irrespective of the number of iterations. So it has taken around 32 weeks.
32 weeks for a particular project.
A particular project, total number of weeks. The time it was the design was given till the time it was delivered to the customer. So what is the total number time in terms of weeks that has been taken?
But how I cannot understand, because one project, how many like number of weeks? No, I don't understand, sir. This one.
Yeah, the aim is to
project number, and this is a weeks here.
That means this one, the x-axis is number of projects actually. It's not for one
not
project.
Number of projects. No. Project 1 is taking 30 weeks. Project 2 is taking 45 weeks. Project 3 is taking 40 weeks.
Understand. Yeah, clear. Yeah.
Okay. So probably we had check the p-value, and in this case the p-value is more. So, but sorry, you want to add here? Probably you are right person to tell on this part.
Yeah, so you'll have to check because we need to do the process capability analysis before, that is before improvement. So in order to do that, we have to establish that the data is whether it is anomaly distributed or not. So we have done the normality test. So when we do that, we are finding that the p-value is coming to be greater than 0.05. So that means we can use the process capability study for normal data. So in the Minitab, you can just go there and select the process capability study for normal data. So because we have established that the data is normally distributed here. Okay.
Thank you. Okay.
So this is again the process capability analysis done. So here our target is to go to minimum 30. So we have kept 30 as the US upper specification limit. So and zero is the, so we want to keep it less than 30 days. So 30 is the USL and 0 is the LSL. So keeping this two specification limits, so we do the process capability analysis using minute. So we are getting the CPK. CP value we are getting around 0.34, but whereas CPK is minus 0.25. So the CPK value is coming to be CPK is minus because here we are finding that our the mean is higher than the USL, right? So the upper specification limit is 30, but average is itself is coming to around 41 weeks, right? So that is the reason, even though process potential is there, we are getting 0.35, but the capability is not there because the mean is very high. So that's why CPK is minus 0.25. So the process is very, very incapable, right? So that is the conclusion from this, and we need to really see how we are going to improve it during the improve phase. Okay. Yeah, carry on, Rajesh. Hello. Hello. Hello.
Hello.
Yeah.
Sir, கேக்குதுங்களா?
Okay. Yes. Yes.
Okay, line cut ஆயிடுச்சு.
Okay. You can share your screen.
Okay, fine. Can you see me, sir?
Yeah. Yeah. Okay. So you can continue. Yeah.
Thanks, sir. Okay. And then we also did another study that is probably had a look of we had two product lines here. One are the switches and the fuses, and then try to have a data split up of them also. What are the areas we are having different what is the timeline of each of these product categories, and if you see it, actually the switches are taking a little more time compared to the fusing timelines actually. So one thing what we observed here.
Okay.
Okay, and probably the measurement point of view, I think probably not into more of a manufacturing kind of thing where we have some components or materials where we use some measuring equipment, so that it's not. So this is more of a data is taken from the complete server. We have a complete backup of the project management system, a server, and the tools. We have DevOps on the server tools actually. So so there is. This measurement system is not applicable here as the data being taken by the server. There is no changes may happen in that actually. That's the reason for this.
Okay.
Coming to the analysis phase. And we also did the regression analysis, and then based on that we got this results in that actually.
So we have kept the number of iterations of the X factor, that is the input variable, and we want to reduce the time, that is a time in weeks, right? So we collected the data on the number of iterations. So that was there in the data which was collected before the improvement. And then that, keeping that as a X factor, that is the input variable, and the time in weeks as the output variable, we did the regression analysis. and we found that the regression was valid, and if you see the R-square adjusted value at the top, the model summary, so 87.63%. So that means 87.63% of the variation is accounted for by the iterations. So iteration is coming out to be a very key key input variable, which has the maximum impact. Go to the next slide. No, the regression.
Sorry.
No, the next one.
We have only this, sir.
No. Yeah, go to the previous one. Previous one.
Previous. Yes, sir.
So you can find that so this is the regression equation we are getting. The v is equal to 22.6. So this is the regression equation we are getting. And then come to the next slide. So we are getting the value for the regression. The p-value for the regression is 0.001. So that means the regression equation is valid. And for iteration, which is the key input variable, again the p-value is 0.05, less than 0.05. That is there it is 0.001. So these two are again, so the iteration is actually the critical input variable, and that is contributing to 88% of the total variation. Right? So that's the difference from the regression. Go to the next one. So we also did a residual analysis. After finding the residual analysis, we are finding that the data is the residuals are normally distributed, and versus fit and versus order, we are again finding a random this thing, randomly distributed upon flow. So that is also the requirement. So we can see that by doing all these tests, we are finding that the regression is fairly valid this thing, and our findings that the number of iterations are having a major impact on the time taken for the new product development, that is established. Right? So the number of iterations is identified as the critical root cause. Okay.
Okay. And then we try to do a fishbone diagram analysis, or probably what is the root cause, or what is the way we can reduce the design iterations. And then we got different ideas from the team on the different parameters what we have been considering, like a man, machine, material, other mother nature. And from that we try to identify what are the key contributors. And then one area what we came in terms actually is probably the simulation might play a vital role, because before we make a sample, that is can try to do a modeling and then simulate them in the tool or a softwares that can give you a result or the accepted result in the CAD model. By that you can come to a decision whether I need to go proceed ahead for this design to the vendor and then spend the money in the proto samples and testing, or whether that will give you a required results for me, or I need to go for a different design or iteration design in the model and then make the design work for my requirement. So that is the thing, what key thing what we observed here. And in addition to that, we got few other material inputs also, like the design team capabilities or the issues from the vendors. We got many inputs from the team.
Okay.
So as I told you, the key outputs where the simulation has been not done. So that gives big surprises in the testing point of view, which we didn't anticipate. And then there is a delay in the vendors, as we have a wrong components on the vendor or improper assembly. We have everything fine, but at the end of the day, the assembly is not done properly. Things goes in the wrong direction. So that is the overall summary what we got. So then moving on to the improve phase. Okay, so what are the actions we have been taken in that angle is actually so let us consider the simulation point of view. So instead of now doing a calculation and the modeling alone, so let us bring in the right tool. For example, we have plenty of tools where the electrical point of view, we have COMSOL or Coulomb, answers, the different tools are there. So we try to have procure the right tool for the right design. And then we also, it's not only the tool, we need to have a right resources also. So normal people cannot handle these tools by themselves. So we need to hire a resource for that simulation. Then we brought in that on place. In addition to that, there is a delay in the vendors. So obviously we had check for the alternate vendors. Then we just support the supply chain team, and there is wrong components, and we try to tighten the quality process, and also we have some clear quality measures in place by the quality team. Improper assembly, that is something what we need to educate the operators, that we took to support our production team, and we did that.
Okay.
Okay, so after doing this, is the overall project timelines or the data captured overall. Probably I can give you a summary of that in the next slide. So if you see here, this gives the overall summary here for you, where you can see here actually this is the data before the simulation and this is the data after the simulation, where we can see a dramatic reduction in the project timeline and in the number of weeks as well as in the iteration point of view. This is the thing what we have captured based on the after simulation data projects.
Okay.
Okay.
So again, now we'll have to do the same test again. We'll have to do the run chart to see that whatever the data we have collected after the project has been completed, improved. Again, whether the data is having any special cost variation. So here we are finding that again the points are randomly distributed above and below the middle line. There is no special cost. So the data is good. The second one is again we wanted to check whether the data is normal so that we can plot the normal. We can do the analysis. We are finding the p-value by in the Anderson method is around 0.216. That is more than 0.05. So the data is normal. So once we establish the data is normal, then go to the next slide. So then we did the process capability after. So here we are finding that the CPK is 0.89. So previously we found that the CPK was negative, that is minus 0.25. So now keeping the same USL of 30. So here we are finding that almost all the readings are less than 30 weeks. So there is a dramatic improvement from minus 0.3 to 0.89. So that means the process has even though more scope is there, we cannot call that as a 6 sigma process. So it will come somewhere around a 3 sigma process or something like that. It's almost a stable process. Right? So still improvement is there. Improvement is possible. It is not. I won't say that this is actually the best possible or the optimized process, but I think it is nearer to a stable process, right? Different from the capability analysis. Okay, next slide. Okay, then we wanted to do the hypothesis testing to see whether the improvement has been significant improvement has been achieved. So we wanted to do a hypothesis testing. So for that, again, the 4 steps you'll have to do. The first one is the run chart, which already we have done. The second one is the normality test, that also we have done. Found the data is normal. The third one is the test for equal variances. So we did the test for equal variance and found that the p-value is 0.059. That means again, the data is having equal variance. Then we did the 2 sample t-test. So go to the next slide. So for whenever you want to have 2 sets of data, we want to do before comparison and the data is not, then we can do the 2 sample t-test for the comparison. So when we did the 2 sample t-test, again we are finding the last row, you can see the p-value is 0.000, right? So that means p-value is less than 0.05. So that means there is a significant reduction in time. So if you see the box plot also, you can see a significant reduction is there. So before improvement, the data was 40.7 and after the improvement it is 17.4. So there is a, you can just see that is a, the overall mean also there is a significant reduction is also there, and you can also see the variations also has reduced drastically, right? You can see the box the height of the box is very high before, whereas that has come down in the after. So that means the variation has also come down and the mean also that has significantly improved. So that is the inference from this 2 sample test. Okay.
Okay, and this is a comparison of the actual theoretical and the practical thing. Because we are doing a simulation, so we need to ensure whether this output what we are getting in the simulation is exactly giving you the output in the practical results. So that is the way how we can rely on the simulation, right? Because we have a big difference in simulation results, then we can't take that as a right method or a methodology to adapt for the all the projects. But we did a comparison here, but this was really excellent thing. If you see the actual simulation of the test, you can see the graph here, and they are almost exactly matching to the practical results to the simulation results. So by that we can come to a conclusion. This can be adapted to the all the projects.
Okay.
Okay. So again, the failure mode analysis. We performed that, and then, for example, what may go wrong here, or what are the failures we may get. For example, again, the key contributions are the resource may not be available. For example, because, as I told you, a resource with a simulation capacity is a hard, tough task here. Actually, that's one thing what we need to have a look. And then there is no proper tool available for simulation. That is, again, we need to have a look of that. And then, whether we are getting the right tool, that's very critical. We should not use a wrong tool for simulation. Either the simulation tool has been up to date, whether they did have the AMCs, and then have a right tool on place with this with all the packages available. That's one thing. Other thing is, biggest thing is the variation in the simulation and practical results. That is a key factor there. That's the thing what we saw there actually. This had a higher rating, but we did a comparison of that, and we found the results have been okay, or matching to the practical results actually.
Sir, I have a doubt actually. Can I ask?
Yeah, yeah.
Yeah, I'm Sisupal Agrawal.
Yeah.
You have written that there is a failure mode in the left side.
Yeah.
Can I say that this is a after failure mode and effect analysis, which you have already shown the before earlier, correct? Am I correct?
No. The earlier what was done was only a high level risk. So that is for the project. So what are the risks for completing the project successfully? So what are the possible risks? So here in the improve phase, we are doing the FMEA for. So he has made the change the process, right? Before the simulation was not there, and now a new process has been changed. So for changing the process, is there any risk, right? So that's what he has identified. And then he has identified that variation in simulation and practice, right? So that means he's suspecting that there's a failure mode, because whenever you do the simulation and whatever you are observing the practical value, then if there is going to be a difference is there, in this may not work, right? Then it may fail in the test code. So for that again, we wanted to do the action taken was compare the simulation to practical test, and we found that the results were 95% matching. So that is why. So this will be the change process. So we will do the simulation. After doing the simulation, again we will do the comparison also. So that is the action we are going to design. So
failure
change
mode
the
is
process. Yeah.
Here failure mode is for process, no, not for the project, correct?
Yeah, this is for the product.
Yeah.
For the process. For the change process.
The process.
And earlier it was for a project,
Yeah,
not for the process.
That was for the project. Yeah.
Okay. So you gave the severity, occurrence, and detection rating based on the process failure mode here.
Yes.
Correct, no?
Yes.
Okay. Thank you.
Okay, then moving on to the control phase. And we had a comparison of this before and after data, and then we can see a dramatic reduction in the UCL and the LCL, where you can see the shrunken graphs here. That gives a clear indication that the process is really within the control. So you like to add any points here?
Yeah, so you can see that the mean has also significantly reduced from 40.73 to 17.64, and you can also see that the mean also, whatever the range was there from between LCL and UCL, so that has also significantly reduced. Same for the range. So mean has also reduced, and the range also, the variation has also come down. So that means we can say that the ideal Six Sigma project, whatever the results we are expecting, so that has been achieved. Okay.
In after IMR chart, after IMR chart, in point number in observation 6, 7, 8, 9, it is continuously increasing, correct?
Yeah.
Can I say that this after IMR chart 6, 7, 8, 9 is not stable?
No, normally
point is not stable.
Yeah, normally I think we are looking for 7 consecutive points which are increasing or reducing. So here we are finding only 3 points, so 7 and 8, 9. Right?
Okay, Nelson will say that if 3 or more points is consecutively increasing, then the process will be not stable. And here are 4 points, more than 7.
Yeah, more than 7. We call that as a rule of 7. Yeah, rule of 7. So if any trend is there, more than 7 points, if any increasing or reducing on the same side of the median, if 7 points are there, 7 consecutive points are there, then we call that as a process is not stable.
Okay, actually, I have heard that. Actually, I have studied that in according to Nielsen, there are 3 or 4 points if continuously increasing. So that I asked. Sorry.
Okay. Here maybe the samples, number of samples may be less because here the 10 projects is
Yeah, correct. Yeah, correct.
yeah.
Sample size is less actually, so that.
Yeah, sample size is less.
Yes, we can neglect.
Okay.
Thank you.
Okay. And then probably we also had a look of the control plans. So for example, once we have what are the kind of control mechanism we are going to have in this actually. That, as I told you, the key factor what will be in the resources not available with the simulation capability. So we need to bring in the resources. And also we need to have internal training within the team members or some buffer resources part of the team who is able to handle the simulation point of view. Again, other big factors, what happens actually, whenever suddenly we come to a day that the tool is expired, we don't have the simulation tool available for doing the task. That is something very normally happens all over. So we need to have a proper renewal mechanism on place with the support of the sourcing team on that part, or we can go for a long-term renewal of the tools. That's one thing what we can follow. Other biggest problem what happens is there are two types of tools available in the market. One is floating license, that is a license installed in a server where any of your employee, say again one resource can use it one time, but it can be used for many employees. Or again, number of packages license to use 5 or 10, many resources can use it up. But the key factor there is actually you need to have a strong internet connectivity or a server connectivity in your office to access the tools from the server. But problem is that if there is a serious internet down or broadband down, or now the current remote working situation, other alternate options is having a dongle based licenses, so that will not have any interruption in the access point of view. The individual license can be worked at any from individual laptops. That's one alternative we can have. We can have one or two licenses in that category so that you can continue the project in case of an emergency like that actually. And then in the vendor component delay, that is something what we need to have a clear work close with the sourcing team or for alternate vendors. And if something goes wrong in the component point of view, then we need to work with the quality team and then get the right component on place. And probably we can implement the quality check in the vendor place itself with the proper checklist or proper dimensions report in there from them when we get the materials. Okay, so overall, what is outcome? What we got from this project actually is probably this. We tried to come to a conclusion that the simulation played a major role in the NPD timeline reduction. Actually, almost 90% of projects has been reduced to one iterations from the after simulation. That's the observation what we had. And then the average timeline has been reduced to 17.5 weeks per project. That's other big achievement what we have, and approximately we are able to have a big saving in the project point of view. That's the thing what we got from the overall after simulation. This is what we obtained. Again, as a project closure procedure, probably I sent an email to my sponsor and then mentor. Then he has to give me approval that your project is closed. Yeah, you are good to close the project.
Okay. Thanks, Rajesh, for this wonderful achievement. I think you've done a very good job. I think within 4 sittings, right, each 1 hour, I think you were able to come to some sort of a. So the basic idea of doing this particular project was to just to show a end-to-end flow, right? So right from the overview, right from the how we are listening to the voice of customer till the how you are going to post. So what are the different what are the critical components of the project, right? So starting from identification of the CTQ, then operational definition, then process capability study, then seeing whether the process is stable or not, and then analyzing, using the statistical tools for analyzing and validating the root causes, then improvement again, checking whether the significant improvement has been achieved through statistical tools, and then control charts, control plan. So this is actually the full end-to-end documentation or the procedure which is needed for doing a Six Sigma project. So any views or any comments? Maybe Satish have a quick comment.
Yeah, sir. Maybe initial stage I was not there.
Okay.
Now, two questions. One is after your approval, sponsor approval, then it is going to the company for implementation. No, actually, it will be.
Yeah. So you'll have to hand over to the process owner. Like
So
he's done a project, maybe
yeah,
he's actually in the black belt. So once he's
yeah.
completed, then you'll say that this is what is going to be the change in process, and he will hand over to the process owner who is actually.
So that will be implemented for further actions.
Yeah,
Okay,
yeah.
same. That is one question. But the another question, sorry. Initially, I was not there. Maybe I'll lately join. So
Okay.
initially, the iteration was selected as a basic cost. No, sir, actually. And
Yeah.
earlier, when we were discussing, there are other causes also. Like my question is, how you choose the iteration is the like major cause.
Yeah, that's why we did the regression analysis, no?
Regression analysis.
Yeah,
Okay.
our aim was to reduce the time in weeks, which was around 44 weeks. So for the average for the 10 projects was 40.4 weeks. So
Yes, sir.
we had the data, and then we also had the number of iterations for each of these projects.
Yes.
We did the regression analysis, keeping the number of iterations at the X factors and the number of weeks is the Y. And then we are able
Yes, sir.
to, there is a relationship between number of iterations and the weeks. So that was contributed. So number of iterations were contributed to around 88% of the total variation of the hours.
Fine.
Selected that.
So when you are no that I could not recall because I have to just go through. Like when we are doing this regression analysis, we are taking other causes also, and we are finding which is the highest one. That is what the way.
Yeah.
Yes.
Okay.
Thank you, sir. Thank you.
Okay. Here's any comments? Quick comments?
Hello.
Yeah.
I have one question.
Yeah.
Before doing regression analysis,
Uh,
have you done cause and effect analysis?
Yeah, that's why the Fishbone diagram he has done, right? Oh,
That is after.
yeah, that is after that. Yeah, Fishbone diagram. Yeah, previously it is better to do a Fishbone diagram to start with, in order to find the number of.
Number of
Yeah.
factors that could impact the output Y, no?
Yeah. Maybe Rajesh, that's a good point. You can just do the first Fishbone diagram on the higher number of weeks, right? So for that, again, what are the different causes are there? Maybe the number of iterations is one more cause. Try to identify all the causes, and then from there only we are going into the regression. So that's a good point. So you include Fishbone diagram for that, right? That will be the Fishbone diagram.
Okay.
Okay, and one more doubt, sir. One more question is, do you select any criteria before selecting that particular project? Which criteria do you consider? I would say
For what?
for selecting this particular project.
No, again, that's why he has given two reasons. One is the customer voice of customer he has given. So that means the new product again it's taking a lot of time. That's why voice of customer, and then again they are late in going into the market. So in order to improve the customer satisfaction, we took the project. And second thing was there was a savings. He was showing that some 700 or 780K will be the annual. So normally for any Six Sigma project, these are the two major drivers: customer satisfaction and financial savings.
Okay.
That is the reason why those 2 points have been addressed.
Okay, thank you, sir.
Okay. Shishupal, your comments?
Yes, thank you, sir. I'm actually first time joined this project meeting.
Yeah.
So really amazing, sir. अच्छा लगा मुझे, and I'm very grateful to join this and witness this project. Okay.
Yeah.
Thank you.
Okay. Riaz?
Sir, it is very helpful session, sir. When I travel with past 1.5 or 2 months, I traveled with Rajesh sir. He delivered a lot of things to personally to me. It is useful for me to do my project in innovative manner and thinking more about the lot of effectiveness to deliver efficient manner to the customers. It's very useful session and very effective one.
Okay. Thanks. Vijay?
Hello.
Yeah.
Very thankful to you, sir. It's very good projection, and I understand very well. And explanation is good, and I clearly understand how we have to select the project and how we have to go through the tools and techniques. Thank you so much, sir.
Okay. So Munsami, I think this is the first time you're joining. So can you give a small introduction? Maybe I think you may not be able to comment because I think you've not gone through the entire project, but maybe you can just introduce yourself. I see you in the group, but maybe this is the first time you're joining. Yeah.
Yeah, no question, sir.
Okay. Okay, so for the next meeting, so is there anyone who is volunteering or preparing to come with some project or something like that? So what should be the agenda? So this, as I told you, this is for you to to encourage you to take up some projects. So if you have the real data, we will work with the real data. Otherwise, we will use some sort of a dummy data in order to really see how the flow, what type of tools we are going to use, and when we are to use that. So maybe I would request either Satish or Shishupal or Munsami or Sir to come out with some projects. Then maybe it is not necessary that you will have to complete the entire project, but at least some phase or analysis phase or something like that. So the idea is that right now we have got one this thing from maybe sort of a manufacturing where it is a design oriented this thing. So maybe I think here we are having participants from manufacturing and KPO and all those things and all. So the idea is that if you are going to share the projects, right? So your manufacturing can person can understand how these concept and tools can be used in the services, and the service person can really know how it can be applied in a manufacturing section, so that it will give a vast experience for you, right? So that is the purpose of having this particular session. So if each one of you are coming with some sort of a project, either from your current company or from your previous company, right? This company, you might have worked and then you would have solved some problems, and then maybe we may have some sort of a data or something like that. So we try to put it to this particular framework, and then see how this can be documented and explained, so that the people will understand that, okay, this is what is the problem and this is how the tools were used, and then this was the result we got. And so we are not really worried about what cost saving or what are the results delivered or something like that, but we would like to see how the project progress from one stage to other stage, right from define to measure to analyze what type of tools. Because so right now we saw how the regression tool can be practically used. We saw how the two sample t-test can be used for the validation of the improvement, right? So same way, like if more the same maybe in some projects, for the situation maybe some sort of a binomial distribution or Poisson distribution or some other tools, ANOVA, or maybe design of experiment. So these are all also there is a possibility. So that be a learning experience for the entire group. So that is the purpose. So anyone is volunteering to come out with the project?
Annamalai, sir.
Yeah.
Actually, I've done one project in my current company. This is not a Six Sigma project, but this is a QC story project. We have seven steps and QC story project. With your permission, if it is applicable for as per your current condition, then I can explain after this session or in the next session.
In the next session, what you do is you can just send the presentation to me, and we will discuss it offline, and we will decide like how to present it or whether to present it. We will just discuss it offline, and then we will inform the group, right?
Okay, actually, this is a confidential presentation, confidential project for my company.
Okay, so that is the reason again for Rajesh also it was some sort of a confidential one. So you whatever you would like name or something like that, the description, anything you can change. So even the data you can change or something like that, because data you can just put some different data. But Minitab results you can just say that this was the Minitab result, right?
Okay, sure, sir.
So
I will
the
discuss
data,
with you separately.
yeah. So that is very important, because I don't want anyone of you to really get into any trouble because of this. But whatever the names you can change, the original data you can change, but only you know that, okay, this is the original Minitab output. The original Minitab output you can put, but the data you can change, right?
Yeah, sure.
Okay.
Sir.
Yeah.
Sir.
Yeah.
Could I ask one more question regarding the hypothesis test you had done on this project?
Yeah.
Sir, here could we use paired t-test? Paired.
No. Paired t-test will be applicable when we are comparing the one-to-one. So one-to-one is, say, for example, you are say suppose if 10 people are there, right? And the company is claiming that by after taking the medicine for 1 month, right, continuously for 1 month, then there will be a weight loss around 25% weight loss will be there. They are claiming that, right?
Hello.
So then what we'll have to do is we'll have to collect the weight of these 10 people before taking the medication, and then the weight of the same 10 people after the medication is taken, and then we'll compare one-to-one. So for the same person, what was the weight before and what was the weight after, right? For the person, what was the
Basically, it is
weight?
used to compare.
Yeah, it is compare the one-to-one comparison, right? So here considering the whether the project is one project, so we are not comparing the same project before and after, right? So before there were 10 projects that were different from the 10 projects which are after the improvement is there, right? But in the parity test, we will do the for the same thing before and after the change.
Okay, thank you, sir. Thank you so much.
Yeah. Okay. Satish, is it possible for you to prepare something for next week?
Sir, I'm trying, sir, but I cannot commit now because I'm also having some workload. That's why I was keeping quiet. Actually, I'm
Okay,
trying
you
to
just
get actually because what I am doing now actually instead of going in my own company, I'm trying to get some data from the other manufacturing company actually through my friend actually.
Okay.
So it will take some time. That's why actually.
Yeah, sure. Okay, no issues. Okay, so the idea is that whenever we are having, so even I have some project, no, because I have also done as a part of consulting, I have done some 2-3 projects, so I can also present. And then if we are having some specific doubt or you want some clarification or explanation on certain tools or something like that, that also we can discuss, right? So for the next one, I will go through what Chichupal has to offer, and then we will just present it there, and then we will just one or 2 days before the review, then we will present it, right? We will just give you the agenda. This is what is going to be the agenda, right?
Yes, sir.
Okay. Thank you all. Thank you all for your time, and I think you had a good experience, and hope I think this will be able to continue. It should be a great learning experience for all of you. Okay.
Thank you, sir.
Yeah.
Thank you.
Thank you, sir. Thank you very much, sir.
Thank you, sir.
Bye.
Thank you all.
Yeah, thank you.